back for more examples. So again, my game plan, my first step is to factor both the top and the bottom so I can find the zeros. Alright, so we'll follow through in this case. So the bottom, when I factor it, it's x plus 1, x minus 1. The top, I think is minus 4 and minus 1. Yep, that'll do it right there. And so we automatically see we have a little bit of an issue, right? This factor is the same. The zeros upstairs are 4 and 1, and the zeros downstairs are 1 and negative 1. So we have a matching 0. So that means, right, from what we have, is this, one of the zeros in the denominator gives us a vertical asymptote. So our VA is happening at x equals negative 1. And since the 0 in the numerator that's left is this, so 4, 0 is our x-intercept, and then we have a hole in the graph at x equals 1. Alright, so that's basically what I can tell. So I've got where I'm crossing the x-axis, I've got where my vertical asymptote is, and I now know where my hole is just by evaluating where my zeros are. And so this function now, right, the way we're going to be working on it, this function behaves like x minus 4 over x plus 1. So all our analysis is going to be on that because we have it in simplified form. So my next step, since we do have a hole, right, we got to locate where is that hole. And so we evaluate that in the simplified function. So our function at 1 is 1 minus 4, 1 plus 1, that's negative 3 over 2. So the hole is at 1, negative 3 halves. So there's our hole in the graph. So my next step, step 3, is to talk about the end behavior, right? What are we doing as x gets bigger positively or negatively? So in this case, the degree upstairs is 2. That's equal to the degree downstairs, which is 2. So my lead coefficient, right, divided by my lead coefficient gives us a horizontal asymptote of y equals to 1. And then my final step, possibly, hopefully, is to find the y-intercept. So in finding the y-intercept, we look at f of 0. And so in this case, as a matter of fact, you can plug it in here. 0 minus 4 and 0 plus 1 gives us a negative 4 over 1, which is a negative 4. So the y-intercept is at 0, negative 4 for this graph. And so hopefully that's enough information. We can only tell by graphing what we have. So let's start with the asymptote. So our vertical asymptote, one of them is happening at negative 1. The horizontal asymptote is occurring at y equals 1. So we got that. One of my points I can graph is 4, 0. So that's a point on the graph. Another point I can graph is 0, negative 4. So that's a point on the graph. And so I think that's about all. Oh, and the hole. The hole is at 1, negative 3 halves. So 1. So there's a hole in the graph right there. So at this stage, if I put everything together, right, for sure on this side of negative 1, right, on the right side, there's how my graph needs to be behaving. And what I'm going to use is the fact that the multiplicity on the bottom is equal to 1. So as this side goes to negative infinity, I know on this side it has to be going to positive infinity. So what that tells me is on this side, the graph has to be pretty much doing that. Alright, and so yes, I was able to get, using all the knowledge that we've brought into play here, I was able to use all of that to pretty much come up with a pretty good sketch of what this function is going to look like, including the hole. Alright, we have a hole, we have a vertical asymptote, we have a horizontal asymptote, we have a vertical asymptote behaving where the graph is truly ripping itself apart. And so I'm pretty confident that, for the most part, that graph is right. Of course, if you want more details, you can always do more point plotting. Okay, but I think I've got it. I'm pretty confident, and you guys can check it on your graphing calculator. Right? I'm going to go on to the next problem. So what's my first step? Let's find the zeros. So the bottom factors is x minus 2 and x plus 2, and the top is x plus 3 x minus 2. Make sure I got that right. Yep. And so again, we see that we have a common factor. So this reduces to x plus 3 over x plus 2. And so x equals negative 3 is the only 0 that remains upstairs, and x equals negative 2 is really the only 0 that remains downstairs. So this tells us the following. My x-intercept is occurring at the point negative 3, 0. My vertical asymptote is occurring at x equals negative 2. And because we had a common 0, I have a hole in my graph at x equals to positive 2. And so my next step then, so that pretty much exhausts step 1. Step 2, since we recognize we have a hole, I got to go find it. So I'll evaluate the function in the simplified version. So that's 2 plus 3, 2 plus 2, that's 5 over 4. So my hole is located at 2, 5, 4. So I now know where my hole is, I know where an x-intercept is, I know my vertical asymptote. So what's my next step? What's my end behavior? Right? So what's going on as x gets large, positively or negatively? Well, I see that the degree upstairs is 2, and that's equal to the degree downstairs, which is 2. So my horizontal asymptote is lead coefficient divided by lead coefficient. So y equals 1 is my horizontal asymptote. And then what I at least at the very minimum do, step 4, is at least find my y-intercept. So when I find my y-intercept, we have f of 0. This is equal to, I'll do that in the simplified form, 0 over 3, 0 plus 2, we get 3 halves. So 0, 3 halves is our y-intercept. So hopefully that's enough information to put all of the graph together. So let's see, my vertical asymptote is at negative 2. So we've got a line we'll never cross. My horizontal asymptote again is y equals 1, so we may or may not cross that, but the end behavior tells us what's going to go on. I have an x-intercept at negative 3, 0, so that point. I have a hole in my graph at 2 and 5 fourths, so that would put, that's a little bit over 1, so the hole is located right there. And then I have a y-intercept at 0 and 1.5. Right, so that puts us about right there, 3 halves. So I actually think that's enough information to gather this. My multiplicity down below here, my multiplicity is 1. So because of this guy here, in this direction I got to hug the horizontal asymptote, and in this direction I've got to be going down. Over here in this direction, oops, there's a hole there, sorry, that shouldn't be cut. We have hugging the horizontal asymptote, and in this direction we better be going upwards. And so there is a really good sketch. Sorry, that should be open right there, but there's a good sketch of what that function looks like based off of all the analysis that we've been learning. All right, and so again, hopefully you can see that just following that game plan, there is a lot of work, there's a lot of moving parts, but you can do this. We don't necessarily need technology to be good math students, but you can check the technology to see that we're right. Alrighty, so there you have it. Do another round of applying this in another video coming soon.